Well, hello everybody. Third time's a charm. This is actually the third time I'm trying to make this video. I've had some interruptions and some phone calls, so I'm going to try this one more time and hope that this goes through clearly. In the previous video, we talked about some factoring techniques, talked about being certain to look for when there is a greatest common factor or not, and potentially how to solve problems when there is an equation involved as opposed to an expression. So the specific focus of this video is to look at what happens when you do everything that you can, but you still don't have A equals 1. So I'm going to share myself with my document camera, and we're going to look at a couple of problems. So the first question that I wanted to look at with you is this particular problem, 3x squared plus 2/3 x plus 14. 23x plus 14. And what I see right off the bat is that there is not a negative to be had in that problem. So we don't need to deal with any kind of negatives or anything like that. Everything is going to be positive, and that's amazing. Then I look for greatest common factor. And that word common is really important because if you say something has a common factor, it means literally every single piece of this problem has to have it. And when I look at this, these two have an x, but this one doesn't. So that's not common. This one has a 3. There's no 3 that goes into the number 23. So this problem has nothing that I could say that it has in common. So when we look at this problem, we have a couple of ways that we could do it. Now, there is the modified diamond, and I know some of you guys really, really like that method, but I prefer to use a guess and check. So I'm going to do some of these problems using a guess and check and some using the diamond. But when we say guess and check, it sounds like we're really taking this crazy method where we're just going to just throw a bunch of stuff at it and hope what happens. But this is really not much of a guess because if you see 3x squared, there's only one way to get 3x squared, and that is 3x times x. And similarly, although there's not just one answer, there could be more than one answer. But when you look at the number 14, there's two ways that could happen. It could happen a 7 and a 2, or maybe a 2 and a 7. Now, I do also know that the 14 and a 1 is a possibility, but I personally usually go to the numbers that are kind of centered in, and I go to the ones later on if it fails to go to the outside when I guess and check. And we've already talked about the fact that there has to be positives. So when I look at this problem, I'm going to use the distributive property. So 3x times x is 3x squared, and sometimes we physically write this out, and sometimes we just do it in our heads and just think our way through it. But if I distribute, I get 3x squared and I get 6x. When I distribute the 7, I get 7x and I get 14. Now, when you look at it, this is promising. I see my 3x squared there. I see my 14 there. But when I look at those two pieces, I do not get 23x, which means this is not the right factor. But if I try that on this following one, similarly, I get 3x squared. But now I get 21x. And I get, when I start distributing the 2, I get 2x and 14. You can see that this is, in fact, what I was shooting for. So when I say guess and check, it wasn't really guess and check. It was educated guess and check, and it actually worked very, very efficiently. Now, sometimes you are not being asked simply to factor the problem. Sometimes you're asked to solve the problem. So imagine, if you will, someone asks you to take 3x squared plus 23x plus 14 equals 0. Now, factoring becomes a tool. It's not the answer, but a tool to help us get the answer. And so what we need to do now is take a look at what can I do that would make either one of these pieces equal to 0 so that their product would be 0. And this one is the one most people like a lot, is that if x were -7, then this piece would be 0, and 0 times anything would be 0. Or -2/3 would be the answer for that side of the story. And so again, now if your problem was not equal to 0, like let's say the 14 or the 23x were on the other side, then you just move it across the equation by adding it or subtracting it to make 0 happen on this side. Okay, so for number 2, we're going to look at a problem with a similar level of difficulty. We're looking at this guy right here. Now notice that there's no equation, so I cannot solve this problem. All I could do was factor, and that would be the directions for this side of my paper, is just to factor these. Anything on this side is going to have an equation, and I'm going to try to solve it. So one of the strategies that some of you guys have been favored is this modified diamond. Some people draw the full diamond. I just draw a box. But how we learned to do that is we'd put the product of the 5 and the 6, which we call A and C, right here. Now, again, you should know this, but just in case you had forgotten. And then we put B right here. That's the B value. And then we think of what numbers would have a product of 30. And I know everybody thinks, oh, it's got to be like a 6 and a 5. 6 times 5 is 30, but that's not the only one. We also have 15 and 2 would be 30. And of course, if the product is positive, but the sum is negative, that would make both of these values negative. So how we proceeded back in the first semester when we learned how to do this, we learned that we would take the ax squared portion and we'd put it in one portion of the box. We'd put the c portion in the bottom right corner of that box. And then we would borrow these two pieces right here and put the x back in, because if you look at this, negative 15x and negative 2x is in fact negative 17x. So this box, this diamond helped me figure out how to break it up. And then all we have left to do is look for what could I do to find what they have in common. And I see that these both have a 5 and an x in common. And now I can just think, oh, well, shoot, x times negative 2 is negative 5x, and 5x times negative 3 is negative 15x. And my factor would therefore be 5x minus 2 times x minus 3. Now, just like this previous side over here, let's just pretend for a second that somebody asked me to solve this problem, and I just approached this 100% separately. When is 5x squared plus 6 equal to 17x? Well, the first thing I would choose to do is I would like this to be equal to 0, so I'm going to subtract 17x from both sides. And so I have 5x squared minus 17x plus 6 is 0. Now I have a factorable situation. I'm kind of where I was over here. I would go through that process to factor it. Now factoring is not the solution, but a tool to help me find that solution. And just like that previous problem, I could look at it and say, well, what number would make 0 happen? This one would be positive 2/5, and this one would be positive 3. I have a total of 4 questions in this particular video that I wanted to study with you guys. This was just showing you the guess and check version versus the modified diamond version. Number 3 I put in there specifically because occasionally someone will come at you with a problem like that, where this is not a quadratic trinomial, this is called a quadratic binomial because there's only 2 terms. So again, I'm going to go back to that greatest common factor idea because neither one of these problems had a common factor, but as it turns out, this problem does. Both the 12 and the 27 have a 3 and an x in common, which would leave me with a 4x and a 9. And so that's actually pretty easy. Notice this is a simple problem. If you graphed y equals 3x or graphed y equals 4x minus 9, they'd be simple lines. That actually tells you you can't do any more. If you ever could consider each piece as a y equals and they were linear, you're done. You don't have any more to do. But similar to those other problems, if someone was asked you to approach a problem like this, we would start by factoring it. And I don't want to like talk down to anybody, but this is a particular issue where some students have had troubles. My students historically have done very, very well when we have these stories like this. But when you have a problem like that, we have a lot of students that struggle. And so if you wanted to, it might help to put a parentheses around that, just like you had a parentheses around this, and then they went, oh, how about -3? That's not the right answer though, because 3 times -3 would be -9. And we want something to be 0 because the only way that a product can be 0 is if one of the pieces of that product is 0. And as it turns out, if you were to make x 0, 3 times 0 is 0, and 0 times anything is 0. But you know, you could look back here. 0 squared times 12 is 0. 27 times 0 is 0. And 0 minus 0. It's a trivial answer, but x equals 0 sometimes can be a great little answer. And the last question that I wanted to look at with you, which I'm not going to choose to solve this time, I'm just going to go ahead and show you the factors, is a question that sometimes you look at it and it may actually look a little bit scary. And that's 36x squared. That's actually 36x cubed. I've got 30x squared and a minus 24x. Now, I get it. That question looks really big and scary. There's big numbers and there's all sorts of stuff, but we can cut it down to size very, very quickly because I noticed that every single one of these pieces has a 6 in it. 6 goes into 36 and 30 and 24. I also noticed that every single one of these three terms has an x in it. So if I took out the 6 and the x, if I take one of these x out of those three, I would have x squared. 6 times 5 is 30, and I had two x's. I took one of them out. And then I've got 6 goes into there 4 times. Now, I already did the modified diamond earlier, so I'm just going to choose to go with the guess and check this time. And notice that 6x squared is 3x times 2x. It might be 6x and 1x, but like I said, I usually start with the numbers in the middle, and then if that fails, I go to the outside. And my first guess, because this is called guess and check, I told you I go to the inside out, I would try a couple of 2's. But if 2's don't work, keep in mind you could also get the number 4 using a 4 and a 1. Now, what jumps out at me is if I try the distributive property, you can see the 6x squared, which is great. You can see the 4, which is great. That's what I want. But when I try to distribute here and here, I would get two even values. I get a 6x and a 4x, which cannot possibly equal to 5. So that cannot be the right answer. I cannot take a 6x and a 4x and get a 5. But I can get that if I put a 4 here and a 1 here. Notice I still have the 6x squared that I wanted. I still have the 4 that I wanted when I distribute the 3 by the 2 and the 4 by the 1. But right here, when we distribute the rest of the way, because I did my 6x squared, but I got a 3 here, I got an 8, and I got a 4. But the 3x and the 4x could make a 5 if I made this positive and that negative. And that actually finishes that particular problem. Now, this one would actually have 3 solutions. If I set it equal to 0, it would have positive 1/2, negative 4/3, and 0, very much like this problem up here. I hope that that was very helpful to you. We'll be seeing you again in our next video when we start talking about graphing. I hope you're having a great time, and I hope that we're going to make the best of this distance learning time. All right, have a great day.